Okay, so here's a breakdown. It's a fundamental theorem of algebra. Okay, so the big idea is we want to look at the degrees. Okay, so here's an example. Let's say f of x equals 3x to the fourth plus 8x cubed plus 2x squared plus 11. Okay. The key number that we care about is the highest exponent, right? So what's the highest exponent you see?
6.
I'm sorry?
6.
What's the
4.
highest exponent?
Oh, 4. I thought it was a 6.
Yeah, yeah. So that is the number that the theorem is really focusing on. It's telling us that this is a degree 4 polynomial. And that tells us we have 4 solutions, 4 total solutions. Okay. And the easiest way to think about solutions is this is a curvy graph, right? So this graph may look something like this. Okay.
Okay.
And the 4 tells us that a possible behavior is that the graph is going to hit 4 points on the x-axis. Okay, so there's the origin. So intersection, 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 intersection. Okay. So we call these solutions roots or solutions or x-intercepts. Okay, makes sense so far?
Yes.
And if it's degree 3, then we're expecting the graph to hit the x-axis 3 times, right?
Yeah.
But that's only for real numbers. Okay, I'll talk about imaginary in a little bit, but at least you have a visual to kind of help you see quickly that how to interpret, what that highest exponent tells us about the graph.
Yeah.
So this is called standard form because there's no parentheses.
Mm-hmm.
We also have something called factored form. And factored form looks a little bit different because there's parentheses involved.
Okay.
So let me do a function that's in factored form. Okay, you see how it looks a little bit different than standard form?
Yes.
Now, if it's in factored form, we can also decide what the degree of this polynomial is. If you had to guess, what would be the degree of this polynomial?
Would it be 2 to the exponent?
So we see the 2 here.
Okay.
But are these the only 2 x's in the problem?
No.
How many more do you see?
I see 3 in total.
So we pay attention to the exponent. Okay, so the 2 tells us there's 2 solutions. This one has an exponent of what?
Would it be 1?
Yeah. Anything that's 1, we don't write. It's hidden.
Yes.
And this is also
1.
So how many total?
Oh, I'm sorry, 4. I'm sorry.
4. Yeah. 1, 2, 3, 4. So we find we count the solutions a little differently, but if we were to get rid of all the parentheses and full everything out, it would be a nice number like this. Okay. But if it's a factored form, we have to count 1, 2, 3, 4. So this is a degree 4 polynomial.
Okay.
But the nice thing about factored form is that we can quickly we can find the actual solutions. Here, all we know, unless we go to Desmos, you know, we know there's 4 solutions, but we don't know exactly where they are unless we did a little more digging.
Yeah.
But here, we can find them quickly by just setting all the parentheses equal to 0.
Yeah.
Okay. So every parentheses will get its own equation. Okay, so if I solve for x here, what's x equal to?
X equal to is 1. X equal to 0.
What do we do to move this 1 here?
Put a 1 under and put it on the other side.
Do we need to make any adjustments before we move it to the other side?
You need to subtract it like by itself, but
Yeah.
with a negative positive.
So this goes away.
And you want to go to the other side.
So x equals what?
X equal 1 then.
What's 0 minus 1?
1.
Negative 1.
Oh, it would be consensus switch. Okay.
Yeah, so it's like, you know, negative 1 plus 0 or 0 minus 1, it's always going to be negative 1. So basically, you're taking that number and you're changing the sign when you move it to the other side.
Okay, so if it was negative and I did the same thing, it would be positive 3.
Right, right. So here, this one is positive 3, right? Sign
Yes.
will always change. All right, we have 1 solution. We have 2 solutions. We're looking for 2 more. How would you go about this equation?
So since it has the exponent of 2, for first, do we need to move to 4 first?
Yeah, let's do that first.
Okay, so plus 4. So when it do we exponent 2 equal 4?
Mm-hmm.
Then can you just divide that with the exponent 2? Or no?
Yeah, there's something that we do. Do you know what it's called? How do we get rid of this exponent too?
Do you put like another 2 to cancel it out?
Say it again.
Like, do you put another 2 to cancel it
Another
out?
2. Not exactly. We have something called a square root. Have you heard
Oh,
of that?
yes.
Oh, actually, before we do that, let me I want to point something out here.
Okay.
X squared equals 4. Okay, before I show the math behind it, let's just think about what this means. Okay, if you see x squared equals 4, what that's telling us, or what that's asking us to find, is we're trying to find 2 of the same numbers, or if I multiply those same numbers, I get 4. So this is the same thing as saying x times x equals 4. Okay, that's what x squared is. X squared is just x times x. So even without doing the math here, what are 2 numbers that multiplies to be 4? 2 of the same numbers that multiplies to be 4.
2 times 2.
Yep, so that's a solution. That's a solution. Okay.
Okay.
Now, that's only one solution, though. Can you think of another set of 2 numbers that multiplies to be 4? But they have to be the exact same.
No. Exact same, no.
Mm-hmm.
So this is no other one.
There is.
It is.
Mm-hmm.
Wait, 2 the same numbers?
Yeah.
Oh, -2. -2.
There we go. Okay. So you're able to discover this without having to go through square roots. But
Yes.
but I think it's good to kind of, this is going to help us, will help me to bring up imaginary solutions in a second. But right now, this makes sense, right? Negative 2 times negative 2 is 4. That
Yeah.
makes sense. 2 times 2 is 4. Okay, we're good there. Now, from a algebra perspective, we can take the square root of both sides. You know, square root of 4 is 2.
Yeah.
But just remember that anytime you take the square root of both sides of an equation, there's always a plus or minus that shows up.
Yeah.
And so x is equal to plus or minus, and you know square root of 4 is 2. And plus or minus 2 is not anything different. It's just people don't want to write these numbers multiple times, so they write it like this. But we just have to understand that this is really because people don't want to write out a bunch of numbers, so they do it this way. But it's the same thing as this. So if you count 1, 2, 3, 4. 4 solutions.
Yes.
Okay.
Mm-hmm.
Now, the nice thing is that if we have these 4 solutions, we have a lot more specific information about how the graph, where the graph is hitting those x
Yes.
intercepts, right? There's one at -1, there's one at -2, there's one at 2, and there's one at 3. And these are all points that the graph is going to cross through.
All right.
Okay. Now, these are 4 solutions. We call these are 4 real solutions.
Mm-hmm.
Because these are numbers that we can actually find on the number.
Okay, I get it.
Negative numbers, real numbers. It can be decimals even. Decimals are numbers that you can find on a number line. It may not be pretty, but you can kind of estimate where it is going to land. Okay, so you're good with real solutions. Let's talk about something.
So would imaginary be the one?
Yeah, we're going to talk about that in this next example here.
Okay.
Let me give you another factored form, and then I'm going to have you try this. See if you can find the solutions and see why some of these look a little different.
Okay.
Hold on, let me change this a bit. Okay, so first off, what's the degree of this polynomial? How many solutions are we staring at? Yep. 1, 2, 3, 4. We know this is the 4th degree polynomial. We know there's going to be 4 solutions. But now we're going to be looking and finding them. Okay. All right. So how would you start this?
First, I'll put both of them equal to 0. And then
okay. Do this side first.
Then we'll find the square root.
Before we do that, though, let's...
I'll move 8 to the side. Yeah. So plus 8.
Okay.
So now we find the square root. You said 2 of the same numbers can go into.
Mm-hmm.
2 of the same.
Don't forget there's plus or minus here, right?
Minus, yes, sir.
Now, is this going to be an easy number to find?
No.
Why is that?
Because there are 2 numbers that don't go into it.
Yeah. Because I know 2 times 2 is 4. 3 times 3 is already 9. So it's going to be something like 2 point... It's going to be some decimal, right?
Yes.
Otherwise, there's no whole number that will get me to 8. So usually when we realize that this is not a perfect square, we just leave it alone. We know it's going to be some decimal number, but we're not going to mess with the decimals. We're just going to say, hey, these are the solutions. If you want to find the decimal, plug in the calculator. But
okay.
But just to kind of give you an idea, it's around 2.8. We know somewhere between 2 and 3, so it's about 2.8. Okay. Now, these are still real numbers. It's not pretty, it's decimal, but it's still a real number because you can locate it on the number line, or you can have an idea where it's going to land on the number line.
Yes.
Okay. So these are 2 solutions. Okay. All right. We're looking for 2 more, right? There's the 4th degree polynomial.
Okay. So
all right, try this one.
You move the 9 with -9. And now you find the square root, and it's 3.
All right. There is an issue here.
Oh, because negative is less than 0?
Yeah. What's the problem? X squared equals -9. If we go back to what we were doing before, just trying to reason this out, why does this not work?
You can't find it on the number line, on line.
Okay, before we jump to that, is it possible to find 2 numbers that multiplies to be -9? 2 of the same numbers that multiplies to be -9?
No.
Why not?
Because if you do 2 negative as a positive, it's just
right.
You can't.
Right. So we only have 2 choices, right? Either 2 positive or 2 negatives, and both of them are giving me positive. So
Yeah.
we already know that, okay, we're running into some problems here. This doesn't fit into the rule that we're used to. But we still want to keep track of these solutions, even though it's not in this real number system. Algebraically, it's still showing up. We still want to keep track of it. So we call it, we put it into a different number system, and we call it imaginary number system.
Okay.
But just because it doesn't quite fit into these rules, so that's why we do it. But the way we handle it is because whenever you see a negative inside a square root, we just indicate the fact that there is an imaginary number going on.
Okay.
So we pull an I for that negative, and that just gives us indication, okay, we're dealing with an imaginary number. We're in a different system now. And then we can work with that square root of 9. We can make that square root of 9 to 3. But then the I is already telling us we're in a different ballpark here.
Okay.
But we still have 4 solutions, though. 2 real and 2 imaginary.
I see.
Okay.
Mm-hmm.
Now, something to keep in mind, imaginary solutions will always come in pairs.
Okay.
And why do you think that is?
Like, meaning it's paired like the same number because it's imaginary, so it has to like equal the same.
Something with the square roots. Why do they always have to be 2 of these?
Putting square root, it has to be the same.
Something else. Whenever we do square roots, we're always going to have a plus or minus.
Yes.
And the plus or minus is going to basically mean we're always going to have 2.
2 the same. Okay.
2 of the same but different signs.
Yeah.
Does that make sense? Yeah. Yeah. Anytime you have square root, you're always going to have a plus or minus. So these are 2 solutions. Okay. So, okay. Let's do one more, but now we're going to start from standard form into factor form and into solutions.
Okay.
Okay, so now this is in standard form. How many solutions are there?
Is that a 3?
Yeah.
Oh, okay, so 5.
Okay, we only add the exponents if we have parentheses.
So would I make it a parentheses first?
We don't have to. We will, but the thing is, if it's in standard form, all we need to do is to pick out the highest exponent.
Okay. So would it just be 3?
Yeah, this is a 3rd degree polynomial. So we know there's only 3 solutions, but now that we know there's 3 solutions, we're going to break it down into parentheses and then solve. All right, so we're going to review factoring methods as well. Do you remember how to factor?
What you mean by
like a greatest common factor
of 3? Would it just be
so? Oh, I'm sorry, I left out this x here.
Oh, 3 of 3 and 2. We're trying to find the greatest common factor of 3 and 2.
Before we do that, we're going to look for something that is shared between all these 3 terms.
Is that the x?
Yeah, they all have an x.
Mm-hmm.
So we're going to take an x from each of them. And after we remove an x from each of them, we're going to see what's left. So if you take an x away from this guy, he only has what left?
The x1 is 3.
X squared.
X squared, yes.
Right, because you take 1 away from him, he only has 2 left. Right. So basically, I'm dividing an x from every term.
Oh, okay. I get what you're saying. Yeah. You're taking 1 away. Okay.
Yeah, I'm taking 1 away, right? So what's the second?
Would it be just x, 2x?
2x.
And 8 would just be 8.
Minus 8, yeah. Good. So we have the GCF out. Next step, we have to go through factoring. This is a quadratic that we can go through factoring. So we're going to ask ourselves, What two numbers multiplies to be -8 and adds up to be 2? So I'll create this little factoring x here. All right, so can you think of two numbers that multiplies to be -8 and adds up to be 2?
At like two of the same numbers?
No. It doesn't have to be the same anymore.
Would it be 4?
4 and what?
Would it be 4 and 2?
Yeah, 4 and 2. But we got to figure out the signs though. 4 and 2 can give me 8. We can combine 4 and 2 to be 2. But what are the signs going to be? We got to figure out, is it plus or minus? Is one plus, the other negative? Are they both the same signs? What are the signs going to be that will allow these two to multiply to be -8 and then add to be a +2?
So would it be -4?
-4 and what?
It would be +2.
Let's try it. So -4 times 2 is -8. That's good. But what's -4 plus 2?
Would it be 2?
-4 plus 2 is going to be
-2.
a -2. So this is not quite right, but we're close. What's another option?
So it'll be a whole new option, or will I just put -2? So I try -2.
Okay. -2 and what?
-2 and 4 again.
Let's try this. 4 times -2 is -8. That's good. 4 minus 2 is 2. That's good. Okay, so we have our two numbers.
Okay.
So we're going to take those two numbers and we're going to put it into our factored form. So +4 and -2. Now we have factored form. Still three solutions, x, x, and x. But now we can set each equal to 0 and find each of the solutions. So what would your next step be?
That's why equal to 0.
Everything equal to 0.
Then, so with the x, it's just x by itself, right? So
that's it.
That's just x. Okay. Then with the 4, put -4 and put it on the other side. Then with the 2, put +2, and just be x equal to
1, 2, 3. Okay, so what's the breakdown? Real versus imaginary. How many real solutions do we have?
Would it be 3 real?
And how many imaginary?
0.
0. 3 plus 0 is 3. Good.
Yeah.
Right. Okay, so let me ask you this. Last question. If I had a degree 5 polynomial.
Okay.
Okay. What are the possible combinations of the number of real versus imaginary?
It could be 5 real and 0 imaginary.
Okay, that's one option. What's another option?
I tried to say 4 and 1, but that wasn't it.
Yeah. Why is 4 and 1 not work?
So it has to be, so it could be 3 and 2 because it has to have 2 of the same numbers.
Has to be
Plus or minus.
Yeah, this cannot be odd, right? Okay, so 3 and 2, that works.
And it could flip and go 2 and 3. No, it couldn't. It could be.
Yeah, 2 and 3 is out. This is out.
So could it be flipped the other way? 1 and 4.
Mm-hmm. There we go.
And that's it.
Good. Yeah, so there's only 3 options, right?
Yes.
Okay. Give me 1 second.